Let's continue our math adventure. We're going to go on and we're going to start to do more complicated equations that have rational numbers, specifically fractions. And so the key concept here is this concept of multiplicative inverses. Most people are like, what is that? Well, you probably already know what it is, because a multiplicative inverse is simply a reciprocal. So we know that the reciprocal means that we switch the position of the denominator and numerator. That reciprocal is our multiplicative inverse. And if you take any fraction times its multiplicative inverse, otherwise known as the reciprocal, it always equals 1. So that's what's going to help us get our variables by themselves. So let's take a look at a one-step equation. It has one operation. Well, I have this equation and I have attached to the variable 4/7. I know I need to get the variable by itself. That means I need to get rid of 4/7. And I know that anytime I multiply a fraction by its multiplicative inverse or its reciprocal, it equals 1. And that coefficient of 1 is what I want with my x, because I want one of those x's. So what I'm going to do is I'm going to come and I'm going to multiply this side by the multiplicative inverse or reciprocal. The second I did that, I went out of balance with my equation. And I have to always remain in balance, so I need to pull that balance back up. That means whatever I do on one side, I have to do on the other side. Now, these will cancel out because they always equal 1, and I'm just left with x. Now that's a negative times a positive, so I know it's going to be negative. And this is a whole number. I can always put it over 1 because I want to do a numerator times a numerator, a denominator times a denominator. Well, 12 times 7 is 84. 1 times 4 is 4, so I know that's 84/4. Now, I don't want to leave it as an improper fraction, so I need to change it back to either a mixed number or a whole number. So in order to do that, that negative sign is going to follow it, but remember, that's just a division problem. The numerator is always inside the symbol, the denominator is always outside the symbol. Now I just divide. 4 goes into 8 twice. 2 times 4 is 8. I bring down that 4. 4 goes into 4 once. That is 4. My answer is -21. So let's take it up a notch. What if we have a two-step equation? Well, it's a little more complicated because I have two operations. I can see I have multiplication there and I have addition there. So I always start on the side that has the variable, but I need to get rid of this plus 4/5 first. Well, we know we use inverse operations, and whatever I do on one side, I do on the other. Now, this is a subtraction problem. I might want to change it to plus the opposite. So I'm going to rewrite this as 1/3 plus a -4/5. Okay, so when I do that, I can see I don't have common denominators, and I have to have common denominators in order to add or subtract fractions. So I'm going to find its least common denominator, otherwise known as least common multiple, and I can see that both of these are going to go into 15 because 5 times 3 is 15 and 4 times 3 is 12. So there's an equivalent fraction, but remember that's a negative. And I know 3 times 5 is 15 and 1 times 5 is 5, but that's a positive. Once I have those common denominators, all I have to do is bring down that denominator, but I have to think to myself, I have 5 positives and I have 12 negatives. I have a lot more negatives. So I know my answer is going to be a negative there, and I'm going to take the difference between 12 and 5, which is 7. So I'm not done yet because I still have this -11/15x on this side. Well, now I'm going to go back to that multiplicative inverse, and I'm going to multiply this side by the multiplicative inverse. Now this was negative, so I've got to keep it negative. And I'm going to reverse the position of that denominator and numerator. But I just went out of balance, so whatever I do on one side, I have to do on the other side. We know that These will cancel out and equal 1 because they always do. It's a rule of math. And a negative times a negative is a positive, so I'm just left with x, which is what I wanted to. Now, here it's a negative times a negative is a positive. I don't have to worry about common denominators when I multiply, but I do look along the diagonals. And I can see right there, I can divide both of these by 15. So it really becomes 7 times 1 over 1 times 11. So my answer is 7/11. Looks complicated, but you just need to follow your steps for a two-step equation, but you do have to remember all the rules of fractions. Tough adventure, but I know you guys can do it. Are you up for the challenge?